So to finish off our reactions lab here, I'm going to demonstrate for you station 7. What I have on the left here is I actually took 30% hydrogen peroxide. I diluted it by a factor of 10, so this is roughly 3% H2O2. We're going to be watching the decomposition of hydrogen peroxide, exactly the same reaction that we did in elephant toothpaste, except this time instead of adding the soap and causing it to foam over, we're going to be using a different catalyst. In the elephant toothpaste we had used potassium iodide. This time I'm going to use a chemical, sometimes they call it manganese dioxide. The more correct name here should be manganese peroxide. You'll notice it is this sort of black powder here. I'm going to drop this catalyst in. As a catalyst, we know it speeds up the reaction. It causes the decomposition to happen very quickly. We're going to make some physical observations here. Because the reaction does end up releasing a gas, knowing the identity of that gas here, we can actually do what's called a glowing splint test to test whether the gas from our prediction is actually the oxygen that we expect. So let's just give this a go here. I'm going to take my test tube here, pour in my hydrogen peroxide. We're noticing that the hydrogen peroxide here, it is actually already decomposing, but it's not at any appreciable rate. It only starts becoming appreciable when I actually start adding the manganese oxide catalyst inside. So I'm just going to scoop up a little bit of this here. You don't need a lot of catalyst, although sometimes it's a little bit hard to do mixing in test tubes, so let's just give it a go here. So there's the hydrogen peroxide. I'm going to add the manganese peroxide. As I toss that in there, I stir it up a little bit here, make sure the catalyst interacts with all the hydrogen peroxide present. As that's happening here, I'm preparing a glowing splint. You can either gently blow it out here, or you can just tap it on the table. You'll notice that a glowing splint here is practically out. It's about to be extinguished there. As I put it to the mouth of the test tube here, you notice that it can actually relight the splint here. And in fact, because the reaction is continuously producing this gas here, we're expecting this to be 100% pure oxygen. It should be able to actually cause this glowing splint here to actually relight over and over again. So, glowing splint. Put it to the mouth of the test tube here. That 100% pure oxygen in here is enough to actually cause the fire to restrike. The oxygen in our regular atmosphere is only about 20%. That's why if I just hold this glowing splint here out here, it doesn't relight. It's only when we actually test for the presence of oxygen, as that pure oxygen gets released here, we end up relighting the splint. Okay? So, station number 7 here involves taking the hydrogen peroxide, adding the catalyst. You can predict what happens in this decomposition reaction, and just to verify the gas that you actually balance for here, we're actually doing this glowing splint test here, watching the splint here relighting many times. Okay? Thanks, guys.